Hello, this is Egbert Nierop from the Netherlands. I am specialized in backend, front-end challenges, and I love optimizing code and writing beautiful code. And today I'm writing and I'm explaining about using session state through a cookie. Well, today we would consider that an anti-pattern. An architect would say, well, if you use cookie for session state, then you would limit your scalability. However, there are situations where it is justified to use session state with cookies. For instance, when the front end requires huge logic, huge libraries to be maintained by developers for authentication. Also, when the backend anyway uses a slow backend, then why not just cache data and so even improve your scalability. So I will use this presentation. I also introduce the BFF, the backend for front end. So you would solve some login logic for OpenID, OAuth on the backend, and thus enlighten your front end logic and library size. The other topics are session state and application state, which are two different things. You may decide what to use, one of the two or both. So cookies today are a lot more safe than they used to be. You have all kinds of settings like HTTP only, strict, and same origin. So you can minimize the hijack risk or misuse of that. I'm not going to cover all the topics how to avoid hijacking and misuse of cookies, but I will shortly explain how a front-end login sequence would be or could be misused, and that may give you a reason to step over to BFF. And you need, as an architect, to question which of the two imposes a higher risk for my development, and which of the two provides a better total cost of ownership. This would be a proof key. So if you log in using Microsoft Access Library or Amplify from Amazon, this is a front-end library, then you cannot store client secrets, of course, on the front end, but you create a key on the fly, which is a hash code, and that hash code is later being used when the access token is retrieved, and then it's being used to verify the answer. So this can solve the problem when there's a bad guy listening to requests. Well, another reason is that the size and the amount of code required for the front end to support all those login systems, especially when you not only support Google, but you also support Azure or Google, then your development size or the library size can grow quickly and big. While at the back end is not a problem. At the back end for .NET ASP.NET Core, you would add a section at Google or at Microsoft account, set some secret key, and obviously you need some redirect logic in some container where you deal with that, when redirecting back from the third-party identity provider. So how does session state work? Well, ISP Session uses a blob for user session state. It can deal with a gateway, or when the browser requests go through a gateway, ISP Session correctly deals with that, and then it will encrypt the key and the value and only write back if the value or the session has been modified, thus optimizing the resource. A browser is identified by three ways. The first way is a cookie, and the cookie can be configured, of course. And the second way would be an HTTP custom header. If you use an Amazon gateway, API gateway, then it can create such header for you, and then ISP Session can use that header to identify the end browser. It also can use an IP address Of course, it tries to look through the gateway which real IP address is there. Be aware that an IP address today still may not be unique. So make sure that in your case IP addresses are unique and you can really use that to identify a session. I'm going to show you some code later in a demonstration. This is how ISP Session application state works. It differs in such a way that it uses Redis and then key sets. So it uses a set with keys identified by application name, and this way we have JIT optimization, so only just-in-time activation of the value of that key value if it's required. Also, it will write back the key value if it's modified, only then. Also, application state supports expiration notification. Say if you need fresh data every 10 minutes, then this event can help you to refresh the data just in time. Other optimizations I built in ISP Session is dynamic compression. So if the data is, say, more than 2 kilobyte, then we start using compression. So your Redis and your network traffic is not used so much, it's optimized. Also, keys and values are encrypted, as said before. It tries to use native storage of data, so Boolean, byte, integer, datetime, that kind of data, simple data is being stored natively in binary. As soon as we see arrays or objects, then we are using JSON serialization. Also, it can keep track of endianness, so some systems still use big endian, some systems, and big endian CPU support. We convert that on the fly. Said before, it tries to minimize round trips to Redis, and also it tries to minimize heap use for .NET. Here I try to give you justification when to use session state and application state. Basically, if data is expensive at the backend, so if you need a user state and that user state requires a lot of queries or backend queries to a third party, you may decide to use caching of that state. Also, application state, same principle. If it's expensive, use caching. For your front end, if you use BFF, the code becomes hugely more simple. So say if your login already succeeded, you have a session cookie, a valid session cookie, which says you are logged in. You can use fetch, and your API is here, user info. By using credentials include, your JavaScript also includes the cookies that were related to all that, to your session. Now we'll go over to the demonstration. For that I use Visual Studio Code, and in this Visual Studio Code I minimized, let me get the correct one, I minimized the amount of adaptations to the example. I used .NET New and then Web API, and then I added some files. So these files are here. You can, sorry, it's the wrong solution. First, the project file. It uses my external component, so you can add that with .NET add package, NCV, ISP Session. This is the current version. And then we have some files in the root, no more. There's program.cs, a Docker file, and a build script, which is built shell script. First, look at the code. The program file uses the standard stuff created by .NET New Web API, and then this is my section, ISP Session service, add that, and then I set some runtime related configuration. My cookie is called ISP Session, the correlation cookie is called Session Correlation, and then this is an important one. With this setting I define if I use either application state or both, ISP Session state or ISP application state, or both. We go for both, and in this code you can see that the weather forecast example has been a little bit adapted. I inject two variables with dependency injection, the Microsoft standard attribute from services, and then I have application state and session state, and I increment a counter, okay, and then I return that counter. This is what the example does basically. Now let's deploy this. I created a shell script which does that. Docker file, let's look at the Docker file. So this is all pretty much default, and then I added a expose port 9002, and I build it. I add Redis, see, get update for Ubuntu and Debian, and then I add Redis. I add a copy config. The config is also here, pretty much standard, and here I use a password. The password is set in app settings, as you can see here in the connection string, and here you need for ISP Session some values in app settings or environment variables, whatever you want. Here you have the license for deployment, and let's go with it. Let's deploy this solution. Our shell script basically says build it, remove the old container and deploy it. So let's do it. I need sudo. It's done. The previous container is removed, and I can now go to my browser. I already opened it, port 9002. Let us refresh. There, our example uses JSON. Let's refresh it. As you can see, the counter is a session counter and an application counter. If I would close my browser and reopen it, then the application counter obviously would go up, but the session would be reset. So let's do that. Close it. There we go. Let's execute it. It's now executed in the Docker container. As you can see, the app counter now becomes 6 and the session counter is reset to 1. And there you go. Well, that's our demo for today. If you want to see the component, it's here in NuGet. You can just look it up, the latest version information, and you can see the website for more information or a license. So I hope this was informative for you, and I hope to see you back later. Thank you very much.